Hey guys, welcome to ZAPCon 2022, and I'm Venkat. I'm part of the Goldman Sachs team. I'm a security engineer and an associate. So when it comes to my professional experience, I've started off as a security specialist in the last 3 years, and predominantly worked in the machine learning space as a statistical model in the healthcare industry. So I've been involved in testing SaaS, DaaS tools over the last 3-4 years. And outside work, I'm a budding unmanned triathlete and a hopeful pianist. So I have my colleague and global dash lead for Goldman Sachs, Ved, with me. So he will walk you through the architecture after his introduction, and we'll talk about all the different issues that we have faced and how ZAP helped us, different strategic initiatives that we are working on, and some of the future cool projects that you might find interesting to probably take it up, and some of the open source projects along with ZAP that we very keen to contribute to the ZAP community. So over to you, Ved.
Thank you, Venkat. Hey everyone, this is Ved, and I lead the global DaaS team in Goldman Sachs. So I also started my career as a Android developer. Then I moved to security, where I found my peace. And yeah, after that, I started with pen testing for mobile application, client application, and also web applications. Then I moved to design review and security architecture reviews and everything before I moved to DevSecOps space, currently where I'm working in. Outside of my work, I'm a painter, I'm a traveler, I'm a various adventurer. Yeah. So what are you looking out of this session is the problem which lead us to create this application or the project, you may say, and how we solve those problems. Then I will talk a little bit about the implementations and architectures, and then end user initiatives and the future projects where Venkat will be taking care about that. Next slide, please. Yes. So why we build means why we started using ZAP in Goldman Sachs. As Goldman Sachs, we have already started means used a lot of applications, scanners, and what we felt is we need a solution where we can do more. We can customize more according to our security research and everything, because as you may know that sometimes there are a lot of rules and everything available, but that may be not fit for your application. So we do some sort of research on those type of needs and try to customize our scanner according to that to find more precise, streamlined vulnerabilities in our applications. Then another point is scalability. So for example, let's say right now I am scanning something around 700 applications. And after Q1 or Q2, my plan is to scale it up to 1000 applications. So we need a solution where the scalability is really easy. So we don't have to go back, change the servers and everything. So we need a scalable solution. That's the reason we more kind of like look up to the solutions where we can use cloud and or serverless technologies and everything. So, and ZAP is kind of like useful in those spaces. So we started using that. Then we have already means the organizations like Goldman Sachs or maybe other applications, other systems, they have their downstream solution like the ticketing service, the data lakes and everything. So we need an application which can easily be customizable to integrated with these type of solutions so that we can use whatever existing ticketing solution or data lakes which we have. And ZAP did a really great job in that. And then we currently have 3 types of scans, like scheduled scans, which will be running in automated schedules type of things. Then we have ad hoc scans, like if you are a pen tester and you want to scan something, so you can just initiate a scan. And another is event-based scan. So that is really important. Event-based scan, what do we mean by that is when, let's say you are a developer, you are pushing your code to the deployment servers and everything. So it should be automatically picked up after each of the push to the QA or prod environment. So we can find out the vulnerabilities a lot sooner than it is on live, and people will start reporting them. Yeah. So now let's talk about the architecture of what we built. So we didn't want an application which has a GUI because we don't want to control it. We want a complete automated solution. So we skipped the GUI part. We don't have a GUI part because it is a lot faster in the command line way, right? So we created a GitLab job, and we have an application list.json file, you can say, where we use it as a config file, where we have all the endpoint URLs, authenticated scans, kind of like have all the credentials inbuilt, what type of scans we want to do, and if we want to whitelist some of the endpoints and everything, because sometimes when you scan, you try to whitelist the logout URLs and everything. And if you have a controlled scan, then you can use the session files and everything. So these type of information goes to application list.json file. Then we have a GitLab runner, which will read this application list.json file and try to deploy them to each of the Kubernetes pods. So each Kubernetes pod work as a separate scanner. So we mention it here, like a number of pods is n, because as I said already that it is highly customizable. If we want to increase number of pods and everything, we can easily do that. Then we have a Docker file where we have our customized rules and the ZAP inside that. So this Docker file will be picked up by the Conduit managed build. Conduit is kind of like our inbuilt deployment language, you can say. Then it will deploy in each pods, which will start scanning. So after each successful scan, all the findings will be pushed to the data lakes or the findings DB, whatever underlying solutions you have. And if you can see here, there is a credential vault that is actually our secret manager, you can say. So we want to give the application teams that comfort of that their secrets are stored. So we don't want to hard code anything anywhere, and we want to give only access to those pods which can retrieve those credentials while doing the authenticated scan. So that is where we use the credential vault, or you can say the secret manager. Now I will hand over to Venkat to take you through the services and the machine learning part, how it helped us. Go to you, Venkat.
Yeah. So thanks a lot, Ved. So guys, you'd have seen quite a few places mention of Aries, right? So what is Aries? Just to give you guys a clarification on that. So we have rechristened our project Aries within Goldman Sachs. Why? Because we use a lot of downstream services along with ZAP. Just not ZAP as such. ZAP is part of the downstream service that we communicate to, but there are a lot of other tools, custom tools that we deploy along with ZAP, other services that we communicate, which go along with the same project, right? So that's just a clarification that I would want to give you guys. So yes, we had talked a lot about onboarding and talked about how scalability is a big issue for us and it's a priority for us, right? So we have two places where we have automated the scaling part and how we can onboard things much faster. So one is the GitLab onboarding part, right? Let's say you are a new application guy you created and you want to deploy it. And before obviously deploy it, you would want to test it out, right? So what we have documented is create a Jira and you update the JSON config file that Ved has mentioned. So the JSON config file pretty much has a key value pair of all the required APIs that are well documented in our ZAP website, right? So all of these are mentioned in the config file. And for developers who aren't well aware in most cases of what are the different things security scans have, so we have documented it so that they can have a look at what are the things that one has to provide for a security scan to happen. And then you create a merge request from a temporary branch in GitLab for folks who are aware of the whole Git pipeline. And once the merge request is created, the validation in pipeline happens. This validation is pretty much a check on our end if the person who has created the merge request has done the updation according to standards that we have set in our Confluence pages, right? So once this validation is done, the conduit build happens. What conduit is the framework / language Ved was talking about, right? So it's again built by us. So this pushes it to our Kubernetes pods. We have a lot of stateless pods, and the scans get triggered there, and all the downstream services after the scans are started, all the downstream services get activated, and we push it to ticketing services. We push it to development teams from there, our ML models. And if the build fails, if your conduit build fails, and yeah, you have to repeat the process. So, and the process is very similar for onboarding new Dash tools also, right? So you see in the ZAP community, a lot of people talking about a lot of new rules that they want to onboard. They want to test let's say a couple of CSP rules that even I've asked a lot of questions, and Simon has provided great information on how to write your own rules and onboard it much faster. So, and we have a lot of security researchers within our firm who help us in writing really good rules, which are very firm specific, right? So obviously, in addition to what ZAP finds, some rules which are very firm specific that we would want to capture on our weekly scans, on our scheduled scans, like we mentioned before. So again, the pipeline for that again is very similar to what I mentioned. Create a Jira ticket with the rule, with the Jython based rule. For now, we have set it as a Jython only model because we feel Java and Python covers predominantly most of the developer community, right? At least in a fintech space, for that matter. So obviously, after the Jython rules are placed, create a branch, and then rinse and repeat, right? Create a merge request, conduit build, scans. So this is one part of the onboarding that we have completely automated so that we can focus more on writing new rules. Obviously, people can write new rules and submit it for validation, but obviously our job is to write more new rules, help find issues at much faster rate and much sooner, right? Shifting security to the left, the most common saying in the security space, I guess, of late. But yes, this is what when it comes to onboarding, how we have automated that. And Dast and CI/CD. So this is from I know we have an automation framework right now, which actually makes it much faster. But we had started Dast in CI/CD a couple of years back, 2019. 2019. Yes. So we wanted scans to be triggered. Obviously, not in the GitLab runners itself or Jenkins. We're not used a lot of Jenkins, so we are predominantly a GitLab-based organization, right? So we wanted Dast scans to get triggered from pipeline whenever a developer starts, and obviously not every time somebody starts, but probably when there is sufficient time between the first push and the next push. So what happens is we maintain a project, and whenever somebody triggers a pipeline, an asynchronous Dast scan gets triggered in our Kubernetes pod. So we maintain a separate project for Dast and CI/CD in our pipeline. So, and that does the load balancing and everything and pushes it to our Kubernetes pods. And yeah, and if the developer is happy with the results, he uses this as the evidence for a merge request to push it to production, right? So what I'm going to show next is a very simple YAML file that we use, the developers use. Yeah. So send URL to scan is the job that it's a mandatory job that everybody has to use, right? So there are other parameters which are not mentioned here, but you can see that config.json is the JSON file that we had mentioned before, right? It has all the key value parameters, all the ZAP configurable parameters, nothing you guys don't know from the ZAP documentation, right? So everything is there in that file. So obviously they can choose what they want. Obviously we have restricted some of the parameters like exclude URL. So we didn't give them those options, but all the more generic ones, like, what type of authentication. So we have scripts for different authentication, right? So already some of them we have used Selenium WebDriver, some of them we use through code, pass it on with the replacer API. So all of these parameters we pass it on, and from here our maintain maintainer project picks it up and does load balancing and the scans start. Yes. So this is with respect to DAST in CI/CD, which is again very critical, like Ved mentioned. We want the delta between a UAT and let's say a QA to be scanned. We do not want the delta to be missed because somebody just scanned QA and you're straight off to production using that as evidence, right? So that is why we felt DAST in CI/CD was important a couple of years back. And yes, some couple of major challenges. I think most of the community faces that is false positive, right? That's obviously something very critical for us, right? And when we are operating at a scale where you have like 5,000 applications and you're pushing 10,000, right? So that's not the exact number, but we are talking very close to that number, right? So false positive just it kind of eats your head. How many, you can't have so many people testing your false positive on a daily basis, right? So we wanted something which is very sustainable and gives us good results. And some of the other things, obviously, dashboard and ticketing, it's not a ZAP. It was not a ZAP challenge as such. It was more around integrating with the downstream services, like Ved mentioned. We wanted something to connect to a downstream plethora of downstream services that we have. We wanted that capability, and obviously ZAP provided us that. And yes, so some of the major challenges, how we predominantly solve the false positive part, right, was using ML. So this issue fatigue is something that we have faced a lot. I'm sure most of you guys have faced that as well. But when you face close to 1.5 million findings and you want to validate all of them one by one, it gets a little tricky. And obviously you can mark them as false positive in your in the ZAP API itself. ZAP provides that, thankfully. But when you have so many new applications getting onboarded every week, and new APIs, new Swagger files that just have to get onboarded on a weekly basis or a monthly basis, or you would rather focus your time on doing the actual security stuff, writing new rules, than actually validating false positives or getting the true positives out of your way, which you can confidently say, let's say this is a false positive or this is a true positive, right? But obviously ML helped us in that a lot. So the flow, like you can see in the process that we followed is, once the Kubernetes scans are done, we have dynamically, classified these issues based on the different parameters that we have. We have classified them into true positive, false positive. Analysts need to have a look. There's not enough data, and we have 3 more classifications, right? So these classifications will go on to the data lake, and then our one-stop shop, if I can say it, where all the issues are there: dash, SAS, config managers, credential vault, any issues. So we have a one-stop shop there. So all of these classifications go there. So somebody goes there and checks. So we have already an ML model which does like 70 to 80% of our job. And I'll show the accuracy metrics later, which will probably give you some confidence and why we took this approach. So yeah, that's so yes, just with respect to the scanner accuracy. So this was like 2.5 years ago, 3 years ago for that matter. So initially this is what we faced. All of these issues, and if you see cross-domain misconfiguration, so all of this is on test data, obviously. But we found that, on our domains which very similar to the actual site, we found that cross-domain misconfiguration was something, we always felt true positive rates were high. But, we wanted to automate that, take away the manual part. So that's where the ML part came in. You can see that, as you go up from the bottom, you can see the true positive rate drops significantly. So we wanted something where we can actually use the rule-based approach. We did check a rule-based approach as well before venturing into the ML space. But yes, we felt the ML space actually gave us very significant results to opt that. So yeah, so this is again talking about the initial state again. So where each issue stood in terms of confidence for us. and how an ML model could have solved it, right? For all of these issues. And issue confidence is pretty much what the ZAP scanner as such gives us as part of the report. So just talking about ML in our whole AppSec life cycle, right? What were the primary goals? I'm sure with all of those conversations that happen in the Gmail group that we have, right, about how do I tackle false positives? I think that question keeps coming up so many times, and at least I've been active in that group for the last 4.5 years. So that question keeps coming a lot. So obviously every scanner gives that out. Then thankfully his app allows us to customize it a lot. But we also don't want to spend so much time on the validation part. So we just listed out some goals. What do you want to do? And we figured reducing false positives is one of our primary goals, right? So we did that and give out a true positive confidence for an analyst to take a decision. So obviously we have a cutoff above which, if let's say 95% is our cutoff, and if a true positive above 95%, we automatically send it to the developers. We don't send it to the analysts. We send it to the developers, say, remediate it. It's a 3-month fix or a 1-week fix for that matter, right? So fix it. And if it's less than 95%, we'll probably give the analyst, why not just have a look for this alert, not a confidence for the whole entirety of all the rules. But let's say for CSP, if it's 87 or something, we say, okay, it's CSP and it's 87. So let's give it a true positive. But let's say if it's something else, cross domain, and it's 87, we'll say security analyst to have a look. So based on different rules that we have classified. So, and it has worked actually really good. So, and let's say any new security researcher comes to us, writes a new rule set and deploys it. What we found out is sometimes based on context-based models, even the new rules are being validated really well. When we use a lot of semantics and context in our ML models, the new rules have been validated very fast with even less data. So we feel this is a good way to take all our testing forward, the validation part mainly. Right. So just to give a very brief glimpse into some of the fields that we focused on because of context. Obviously, some of the fields that you can see in the data fields part, right, are very common to you guys. You guys would have seen this on a daily basis, right? So app name, vulnerability, and all of that, severity, instance URI. But some of the other things that we felt for context, right? Let's say a business unit, or what's an app name, or if it's a custom rule ID that we have written. We have a truckload of custom rule IDs, right? So if it's a custom rule ID, and if it's belonging to, let's say, a specific business unit, right? So what would be the true positive confidence, right? Would it drop or would it increase based on all these context-based parameters? So we felt these were some of the important things apart from the usual parameters that ZAP gives out. So we did a lot of classification, semantics-based models. So we did a lot of them, and our usual evaluation metrics actually gave us a lot of good results, which I will show in the next slide, right? So pardon me for the clarity here. So I hope everyone can see it. But yes, so we've used over 7 lakh records, right? And this is only the test data. You can see the test size is around 25%, right? Out of the 25%, out of the test data, 25% is your 7 lakhs, right? So we have huge data to work on, and we're still working. We have reached a place where we can say that our balanced accuracy rate is at 94%, plus or minus 5. So we have a low of 89 also, and sometimes we go as high as 99. So obviously our cutoff tells us that goes straight to the developer, no touching that. But sometimes 94 if it's cross domain, or 93 if it's something like an SQL injection. Obviously it's a false positive. But based on these rules, we classify these two positives, right? So this has actually massively helped us. And some of the things that that I wanted to mention along with this are, the metrics part that we have integrated into our Kubernetes pods. How all of these metrics pods that ZAP provides us with actually gives a live status to our dashboards. Right, what's happening in the tool. What's the scan progress right now for different tools. More like a GUI approach, but without ZAP. But all of these APIs make it possible for us to leverage and show, the larger management, or up the ladder, what the current cybersecurity posture is inside the firm, and how developers are actively contributing, how security researchers are actively contributing to the ZAP implementation. So you see a lot of open source projects, with crazy rule sets that we feel like, okay, this should be something that should be part of our system. Why aren't we scanning this? Right. So we have implemented quite a lot of them into our architecture. So we have a purple team infra already set up where we can use any kind of rule sets. In the current implementation, we have OWTF testing framework again, which supports ZAP. So we also have that. So obviously you can write rules in any language you want. Obviously Python is the go-to choice these days. But yeah, so this flexibility that we give to developers and researchers helps us to scale very fast, like we've mentioned. So we can go from 1,000 to 7,000 to 10,000 in probably less than 3 days, right? So that's the scalability we're talking about. And so our future projects mostly involve writing more and more rule sets that we plan to contribute, and in terms of building it, breaking it down and building it, developing new reports, injectable. And what I mean is you get to choose what you want in the report. I'm sure somebody is working on that right now, but these are some of the major projects that probably we would work on going forward. But like always, I think the ZAP community has been quite helpful for us in providing some of the greatest ideas, I would say, and for making it easier for us in implementation 3.5 years back when we started thinking of ZAP at this scale, right? So that we can even push 15,000. So at where we are right now, 7,000, 8,000 odd, can push to 15,000, 20,000 probably in a day or two, like I mentioned. So, and without compromising on any infrastructure or any of our config scanners. So we have made it flexible in such fashion, right? So that's the scalability and flexibility that we have offered to the people inside our firm. So yeah, I mean, hope this gave you an idea. Hope this whole presentation gave you an idea of. Yes, Ved,
also
please go ahead.
Also to add to that, we might open the service for somebody who wants to use this, but that's still in a plan stage. We haven't completely, in a state to open the service.
Yeah, definitely. I mean, it's something that we plan to do very soon. We have open source quite a few of our different SaaS tools, other config scanners that we have built, and we have published it to the world to use. And there are some things that we have built here on top of ZAP that we feel could be very useful. And we plan to probably communicate with the team and make it useful for everyone. So yeah, this is it with respect to scale. We'll be glad to take any questions if you might have in terms of how we did the implementation, config, scanner. But yeah, so thanks for having us, the ZAPCon team, and thank you guys for listening to us.
Thank you.
All right. Awesome, Venkat and Ved. Thank you so much for being here, you guys. Thanks for kicking off ZAPCon 2022. Such a great talk, learning about what is going on at Goldman Sachs and how you guys are scaling ZAP. A lot of great questions in Discord. For those of you watching along and chatting and hopping, make sure to come join us in Discord. That chat will last forever, so it won't disappear like the hop-in chat. So come join us there. So many great questions, guys. You were answering some of them as we were kind of watching the the video there, first of all, 1,000 applications, that is quite a lot. So awesome scale there. But a couple of the questions I kind of cherry picked out of the Q&A there. One was, how did you scale Zap scans when it's using that file-based, relatively slow database when scanning large applications? Do you have a session DB on each pod? And feel free to jump in there and kind of explain that a little bit.
Yeah. So we have different pods, right? So our infrastructure is completely based on stateful pods in Kubernetes, right? So I think I've bugged Simon a lot on the Gmail groups when we started off before implementing this. But the idea is, if we have a session-based approach, we'll have those sessions as NFS in our pods so that we pick it up directly during scans. So we do not push the whole lot while scanning, but we already have NFS storage in our pods, and the scans, they just refer to those NFS storage and pick up and then trigger the scans. So the slow part for deploying, session files, I remember asking Simon once, we have a 500 MB session file, how do I do that? And Simon came back saying, why are you pushing a 500 MB file, first of all? So that was what triggered us. Like, yeah, why are we doing that? And that's when we changed the approach and held all our session files in NFS storage. And then NFS storage is very easy to use. So we just pushed our code, pushed our configs, and make sure they are referencing our session-based file system in our NFS. So the slowness is kind of taken away because we are not pushing anything during our deployment phase. So everything is like running in your local systems.
And also one more thing I wanted to like to add also, that sometimes it's not always about that, but sometimes when we create a default pods, we give really less RAM or spaces, which normally affects the slow scan. And it means once the database is full, it will again going to be more slow, but because we need to give at least 3-4 GBs of RAM to each pod, so that it is easy to scale or manage.
Interesting. When you guys were kind of designing this pod architecture, what got you there? Like, what were some of the? How did you start? Right. I suspect there's a lot of people out there that are in kind of the same starting position that you guys might have been in, and then got to this like massive scale architecture. How did you start?
So we normally started in GitLab. Actually, when we started to run it in the pipelines, and like we are completely bringing our Git server down because every push initiated one scan, and we are normally taking the whole Git so that others were not able to use it. So we had a lot of pushback from the Git side that you cannot use this type of things or something like that. Then we discussed then how will we do that instead of running it inside a pipeline through the Git runner itself. They means we tried to keep the scans outside of the Git. So the Git will trigger the scan, event-based scans, and it will be running outside the Git using cloud or Kubernetes or something like that. So it will be more easy to manage. Then by using, we reach out to these levels where we understood that, okay, this many RAM is good enough for running a scan, because we did a lot of fails tries and most of the scans failed in our starting things, which we thought that maybe we are going in a really wrong direction. But once we keep on adding the stuffs and we reach out to you people, Zap, everybody helped us with small bits of ideas, which lead to this project right now.
Awesome. Couple more questions. Lots of great questions in the Q&A. If you're not in the Zap or in the ZAPCon Discord, make sure to join us there. I'm sure we're going to run out of time here. Lots more great questions. Venkat and Ved will be hanging out in Discord for a little bit and help answer more questions there.
Sure.
Another one that I saw that was really good. How do you manage false positive flagging? Is that only handled on the data lake layer for late reporting?
Yeah. So that was actually a good question. So initially, at first, the idea was to market using the ZAP APIs, but then we realized when you're talking about 10,000, 15,000 plus domains, the scale at which people are just pushing domains, marking it every time didn't make sense to us. Honestly, because we didn't have the time. So we use the ML model. So like Ved mentioned, Discord, scan, report, train, and obviously that week you might have a bad issue. Obviously, bad issue. I mean, bad classification. But after the training, the next time it reports. So that's already it's pushed to the false positive classification in the data lake. So next time, so we have a findings ID with each vulnerability, right? So the findings ID gets updated from true positive to the false positive in the next weekend scan. So you'll have to do with a bad classification for 1 week, but it gets picked up the next time.
So, so normally what happens in ML is like you need a lot of data to train your model, right? So in the start, it won't be that much of effective. So I will suggest just wait around for few of the scans to happen. When you pick up a lot of inputs, scans, and those analysis of those findings and everything, ML model is the best one to reduce the false positive. Plus, we do a little bit of rules optimization according to our organizations, according to our needs. So that also helped in reducing a little bit of false positive.
So you guys are tweaking the scan policy, the
Yes.
ZAP scan policy a little bit as well.
Yes.
Interesting. Awesome.
That is where we started. Then we moved to the ML model because we needed more scans to means false positive to be reduced.
Makes a ton of sense. Another great question I saw in Discord. If you had to start all over, where would you start?
Fair
From
question.
ZAPCon means we started from a server model, then we reached to this. Whenever you need to increase your model, right? That is where the more ideas and everything needs come to the picture. So from the same simple ZAP server model we started, and we scaled it till this. Venkat, if you want to add something.
Yeah, I mean, obviously, now we have a better idea how to go about it. Obviously, we can avoid all the mistakes. Uh, Designing that architecture that we showed initially, that was a painful task because credential scan, authenticated scans was one of our biggest pain points. So yeah, I think we'll have much better idea now, but yeah, I think the learning process was very useful.
That's great. I love that you guys are just casually like, yeah, Venkat and Ved and I, we just invented this whole thing. It was no big deal. Very, very casual. Another question I saw in the Discord that I thought was really good. You guys were answering it in Discord, but how are you handling changes or fixed scan rules from upstream in the ML model? You have to retrain on rule updates, and I know this is a thing, right? Because I've helped push updates to rules and change the rules a little bit and change kind of maybe how they report, those kinds of things. So dig into that a little bit if you would.
Yeah, so with respect to let's say we write new models, right? So we had a new model we had a new rule CSP. And we had one more in dangerous JS functions. We were not able to pick up one JS function, which our security research team said, like, why are you guys not picking it? So we had to add one rule to that. So the thing with what ZAP gives out as vulnerabilities as versus what we report. So let's say ZAP gives out 100 plus vulnerabilities. Like it can report, possibly can report 100 plus vulnerabilities, right? But when it comes down to our organization, they'll just be classified into 15 buckets with 15 buckets.
Yeah.
So they'll be classified into 15 buckets. So let's say even if you write so many rules, eventually they'll be classified into a fixed number of rule sets specific to our organization. So that helps with classification in the ML model. So our ML model goal is to classify those 15 and not the 100 plus what ZAP gives us.
So normally, if the new rules comes, right, the impact will be, for example, let's say there is a new sort of XSS or the let's take example log4j, right? It's kind of a RC, right? So we will be tagging that to RC only. So we have a template model which handles the findings, and we apply the ML model on the findings after the report, like when they are connected to the templates. So if it is new things comings and everything, it will take another 1 or 2 iterations of scans just for the ML model to learn it and use it. So because of the template model, it was easy to handle all these sorts of new rules and customized new rules and everything.
Yeah, awesome. So obviously, you got to have a lot of scan data to make this ML thing work the right way.
Yes.
Interesting insight. One more. I think we can get one more, maybe 2 more in here. Has a session file? You guys were talking about session files and using NFS to do the storage of session files. Has a session file been corrupted in the approach on crash when you use them from NFS? And if it corrupts, how are you handling restore, recreate? And then the follow-up question there is, how much does all of this cost?
Oh yeah, I'm not sure how to answer that, because it, out of 10 times initially when we did, I think it failed 8 times. So
Yeah.
twice it
So
will
it's
scan.
like if it fails, we will pick it up next time. We will
Yeah.
fix the session file. Okay.
Yeah.
Maybe for one scan iteration, because we have a scheduled scan, right? It's not like every time you push only it will be scanned. Next week we will be picking it up. So we have another kind of notification model. Wherever these type of things breaks, we'll get a notification saying that, okay, this is breaks. This has been not working at this place. So we have to look into that. So next scan iteration, it will be picked up. So in the starting, it failed a lot of time, but because of these type of automations, we have the gates in place. It is kind of easy to handle the session file if it is breaking also.
This is a very
And
mature answer, I think, what Ved is saying. Initially, I think we got our hands very dirty trying to understand what's happening. But yeah, we are at, like, I wouldn't say 100%, but 70%, yeah, maturity.
And when we are relying on session files, we have to onboard or update the session files multiple times. So that's the reason, means because if there is a little bit change in APIs or web applications also, we need to update the session file. So we have another set of task of going through wherever we are using session files, we will be updating those session files periodically, so that we will be picking up all the places.
Awesome. For everybody out there who's like listening to your talk going, this is amazing, I want to do something like this. Can you obviously they can't have Goldman Sachs infrastructure. Can you guys kind of give a suggestion or a tips and trick path on where to go or how to maybe get started?
Yep, we can share our LinkedIn handles and everything. We can reach out offline
Yeah,
and discuss.
yeah.
Yeah, awesome.
But yeah,
So,
I think keeping
go
it
ahead.
short, get your hands dirty, and be very patient. Yeah, patience is the most important thing. Yeah,
You can see our hands, right?
yeah.
Awesome, you guys. Hey, thank you so much for kicking off our ZAPCon event today with such a great session. For those of you watching along, remember, Venkat and Ved are hanging out in Discord, so you shoot them questions in there. That will last for a long, long time. So if you're watching this not live, later on YouTube or something, you can also still ask questions in Discord, and we'll get them over. That will get over to Venkat and Ved. You guys, thank you so much for joining us. I'll let you get on with the rest of your evening. Happy ZAPCon.
Thanks, guys. Thanks, ZAPCon team, and thanks,
Hey,
TACOM.
everyone. Have a nice day.
Yeah.
All right, that's it for